Welcome to the Retro Channel. Today we're looking at 3 Xboxes. All of these are non-functional as far as I can tell, and some of them look a lot rougher than others. So all of these are going to need repairs, and I guess we should jump straight into it, and we'll start off with this one over here, and then, you know, let's see what happens. Right, Xbox number 1. It's a little dusty and dirty, but everything looks to be intact. Don't see any major issues. And on the bottom we have, where's the date on these things? I don't even remember. 2003, 10, 11. I don't know if that's the 10th day of the 11th month or the 11th day of the 10th month. Doesn't really matter, I don't think. Looks like this one has been opened before because there are 2 screws hiding under these labels, and we can see that, yeah, they've already been poked through. Let's just power this thing on first though and see what it does. Okay, well, I just plugged in power and I can hear it trying to start up. Oh, and this time it did start up. No, and now it stopped. That was a bit unexpected. I didn't expect it to try and start just from plugging in power, and now it's not. Now it's not doing anything. Oh, it is. It's not. Either way, we're not getting any video out of this, and yeah, it's trying to start up, but is immediately failing. So, could be a problem with the power supply. Let's open it up, find out. So these things all have Torx. I think they're T10 bits. There goes the rest of that label around the outside. So just got to remove these 2 in the middle, and then there's 1 each under each foot. So to get these corner ones, you can usually just pry up on the corner of these feet just a little bit. Just enough to reveal that screw. You don't have to take the whole foot off. Sometimes they'll fight with you. Alright, 6 screws out. We should now be able to pull off the top cover. It may take a little bit of percussion to make it come off. There we go. Well, nothing too exciting yet. We can see the hard drive, which is in this one a Seagate model, and the DVD-ROM is, it says Thompson up the back here, but it doesn't mean all that much. So the next thing we need to do is get these drives out of the way so we can get to the main board and the power supply. Let's see what's cracking. So with our cables unplugged from both drives, we've got a few more Torx bits to get to, and I think these are now T8 bits. There's one right up the front behind the front buttons, one in the middle. Oh yeah, there's one on the other side of the DVD drive. Alright, that should be it. So we can now lift out the hard drive caddy, and we need to unroute this cable from it, and we can now lift out the DVD drive. And here's what we've got on the inside. So yeah, what has happened there? Dare I say that's definitely from the clock capacitor, which is this guy right here, and they always leak in these things. It does look like some of these caps have been changed. Not sure if they're the original ones, but a lot of the time the caps around the CPU here, these ones also leak. But at the moment these look okay, but I think they've been replaced. As far as the power supply goes, I don't see any obvious issues here, and the power supplies in these things are generally pretty solid. I think the problems are going to be caused by this leaky clock cap, and yeah, I'm spotting more and more corrosion as I look at it. So let's get the main board out and try and clean up this mess. Oh, and of course the very crusty screw near the clock cap. Yeah. I think that is it. So yeah, just remove all connectors and every screw that you can see, and I missed one up the back there. And the board should lift out. So you sort of pull it towards the front of the machine as you lift up on it. It's pretty easy to get out, really. So everything down the back here looks fine. Don't see any issues with those caps or any obvious corrosion. And everything over in this corner also looks fine. Yeah, like I said, I don't know if they're the original caps, but 6.3 volt, 3300 microfarads is the correct values for those. And some Xboxes will actually have 5 capacitors here. And usually they're 6.3 volt, 1500 microfarads. But either way works. Excuse me, I've been unwell for the past couple of weeks, which is why I haven't made any videos lately. But I'm getting over that. Yeah, it looks like pretty much this sort of section of the board is where our damage and corrosion is. It looks like it even makes it over to this RAM chip over here. So yeah, big mess to clean up. And that's our clock cap right there, which would have been the cause of all this carnage. So let's get that thing out first. All we need to do is just try and heat up those solder joints. They may put up a bit of a fight because yeah, all that cap juice mixing with the solder sort of forms like a little barrier across the solder, and then it becomes really hard to melt. So I'm just going to try and walk this thing out. I'm not going to bother about trying to get the desoldering gun on it. In fact, I can feel that the legs are practically breaking off, so I'm just going to give it a little twist. I think that'll snap off fairly easily. And there it goes. Nasty thing. So all I'm going to do is put a little towel underneath this and just throw on some isopropyl alcohol and get scrubbing. Well, that's a little bit better after a quick scrub, but you'll probably notice that there are what looks like some empty footprints here. And indeed, I do have a little SOT23 package on the bench, which I reckon went there. And what might be an SMD resistor, like an 0603 or maybe an 0402, probably went in one of these spots. And we might be missing even more components. Yeah, here's one more. So I found 3 components that have basically just fallen off this board due to that corrosion. Not a big surprise, just a little bit inconvenient. And I just found one more. So we've got 3 probably resistors and this SOT23 package. I think we're still missing one more transistor over here. And yeah, possibly that has disappeared while I was cleaning it, but it hasn't shown up on the bench anywhere. So maybe that had already come off and is floating around in the bottom of the case somewhere, who knows. So I'm not worried that those components have come off. In fact, I consider it kind of a good thing because it means they were only just holding onto the board, and no doubt if we didn't sort them out now, they'd just cause some kind of issue in the future. So I'm just going to collect all these up for now. We'll figure out what to do with them later. So I'm going to go ahead and remove these larger electrolytic caps around here. I might even remove this coil just to move it out of the way for now, and we'll get a closer look at what's happened under here. Right, with all those caps and that inductor out of the way, we can get a better look at the carnage here, and yeah, very crusty in these areas. Obviously we're missing a few SMD components here. In fact, I found one more, I think it's a SMD capacitor, stuck underneath this inductor. So yeah, I've collected up 4 of those now, and it looks like we're missing, well, possibly 4, maybe 5. So we'll see how that goes. But yeah, I do want to give this area another proper scrub. And now that those big caps are out of the way, I should be able to get in there nice and tight. Right, things now looking a lot more cleaner, so we shouldn't have any more corrosion happening, but now we need to sort out the corrosion that has already happened and try and reattach some of these SMD components. So this is going to be a job for the microscope. All right, let's see what we got. So coming in from the corner of the board, looks like we're missing a cap at C8G1. Still a little bit of crustiness under these legs here, so I need a little bit of extra work. That is obviously where our clock capacitor was, so yeah, very crusty demons around there. And yeah, we're missing R7G2. R7G1 looks like it's just holding on. Q7G2, R7G3, R7F8. This guy looks to be just holding on. Ooh, did that move? Maybe. C7G7 might be missing. This pad here is in parallel with this capacitor, so I guess they left space for an SMD cap to be used on these boards, or the radial electrolytics. And yeah, still pretty crusty over in this area. Looks like we're missing R6F7. And that pad there doesn't look happy, but I think that's more of a test point, perhaps. That's where some of the other capacitors are removed. Oh, wow. Missing one there, too. Not really sure if these are actually missing or whether they were just never installed, because it doesn't look like anything was soldered onto these pads. That one as well. And yeah, that one, I don't think there was anything originally there. Whereas if we look at something that we're missing, say R7G3, you can see there's a bit of a lump in the solder there where something is actually broken off. So yeah, still pretty crusty in this area. All right, it is the next day, and as you can see, I did some more work off camera, just removing some of this corrosion and restoring some of these solder joints. And to be honest, the best way I found to do that was just to pretty much scrape at the joint itself, cover it with fresh solder, remove all the solder with some desoldering braid, clean everything up, and then reapply fresh solder. And for the most part, that seems to have worked. And it is a very slow and tedious process. I did also scrub it a bit more with some IPA, but IPA doesn't really have much of an effect, if any, on electrolytic capacitor leakage. I also tried this random circuit board cleaner that I got from JCar. That didn't really seem to make a difference either. Dare I say, this is probably mostly IPA in a spray can anyway. I have read some things online about using water and potentially dish soap. I did try that out just on a little sort of test patch, and again, didn't really seem to make any obvious difference. No different than what the IPA was doing. So yeah, even though it is a very slow and tedious process, I found the most effective thing to do is just scratch up any area just to try and break through any of that contamination on top. And then apply some fresh solder. You can also put a bunch of flux on this to try and get it to flow better. So you can see the solder only wants to flow on that little area that I scratched up. And then come in with some desoldering braid. You can also add extra flux here if necessary. Clean that off with a bit of IPA, and you can see it's now looking nice and shiny. And of course, if we apply some more solder to that, it is a ground plane, so it'll take a little bit of heat. But yeah, there we go. And because that's where one of the screws goes, I need to remove that. But yeah, so it is quite slow, and especially if you're doing this around components that are still on the board, you may just have to remove some of them and just keep trying to reflow them. But this seems to be the most effective way to deal with it. And I don't really want to do something that's just going to work for 5 minutes for a YouTube video and then, you know, fail 6 months down the track. I really want to sort these things out properly. So that's the way I'm going to continue doing it, unless anyone has any better suggestions. All right, so let's see. Starting off, this capacitor here at C7G4 came off, so that's going to have to go back on. I had a look and there was no capacitor on, looks like C8G1. There was nothing ever installed here, so that's fine. And I've got this capacitor floating around in the little parts container. In this area, you can really see how much I've sort of scratched away at the board. In fact, I didn't see that little via there, so we're going to have to clean that up as well, because that will no doubt go bad if it hasn't already. Let's just fix that up while we're here. Otherwise, I'll just forget about it. You can see it really doesn't want to take the solder. Wick that off. All right, that's better. All right, anyway, C7G6, I believe, relates to either one of these pads. So we had a through-hole capacitor there, so we can easily replace that. C7G7, I'm not sure if anything was here. We'll have to double check the original footage. This is obviously where our clock cap goes, and yeah, these have two different spaces for this cap. We're not too concerned about this right now. R7G1 is still intact, although I did have to sort of scratch it a little bit to get the solder flowing properly. And I think R7G2 is one of the resistors that has come off the board. So I should have that floating around. Same with Q7G2. R7F9 should be here, and we should also have another transistor here at Q7F4 by the looks of it. R7F8 looks to go across there. And we've got another transistor here. Looks like it said CR6F1. And I think that is it. Oh, need a bit of solder over that so it doesn't corrode. Yeah, everything else in this area, I touched up a whole bunch of it. You can see it's fresh solder on a lot of these things, but I first had to sort of scratch away at it. You can see this one over here I didn't touch because it's mostly okay. I don't think that's going to have any issues in the future. And for the rest of the board, well, we just need to install these through-hole caps. I touched up some things over here, but this is all good. And on the rear side of the board, there was one transistor, this guy down here, that was also in a very sorry state, and you can see that it still doesn't look great. In fact, I'm not sure about that pin there. That could use some extra flux and a reflow. There's also some traces nearby that don't look too happy either. And just here is where the clock capacitor was, so yeah, not a big surprise. That might have to do. Not as pretty as I'd hoped, but it's solid. Not super happy with how the legs on this thing are looking. The pads. This one too. Alright, that might have to do those. Not the prettiest things in the world, but certainly a lot better than what we started with. As for these traces, yeah, I don't like the look of some of these. Let's just reveal what's underneath. So there's still some copper there. Okay, yeah, we can definitely see the copper's started to corrode under that solder mask on some of those traces, so we'll need to tin that up as well. Let's throw on some gooey flux, which has also got a bunch of fluff stuck in it. The things you see under a microscope. Yeah, I think the liquid flux, even though it burns off a lot faster, seems to cut through a little bit better. And it doesn't leave this brown goop everywhere. There goes that capacitor. It's all right. Put that back in a second. Right, those traces should be good, so let's get this little capacitor back on. Just sit there for a second. Alright, I think we can finally move away from that area, but I am still worried about this trace that runs around the outside of the board. Yeah, so this trace around the outside, there are a couple of dark spots there. I think it's much worse further down. Yeah, that doesn't look too great. There's a few more spots as we go, so yeah, a few bits to touch up here. So I went ahead and revealed all these traces just because some of them also looked patchy, just using a rubber tip on the Dremel. But yeah, definitely the outside trace is the one that's the worst, especially in that spot there and these few bits down here. So I wonder if it's actually broken. Let's check continuity on it, see what happens. And yes, indeed, we don't seem to have any continuity on that outer trace. We do up here though, so it is broken right there, I think. Yes, indeed. And the other three traces seem fine, but yeah, definitely that outer trace was broken. Alright, I think all the other traces are going to be fine. Yeah, it's just that outer trace, and you can see a couple of spots where there's no solder at all, so I'm guessing it's broken around this area here as well. So we're just going to run a bodge wire straight across all of this. So all I've done here is expose a little bit more of this outer trace on either end. This is just going to make it a little bit easier to solder our bodge wire in. So I think this is like 30 gauge kinda. So we would just want to make sure that's firmly attached. And then if we go down the other side, it needs to run up to, focus, Q. It needs to go up to this point around here. So from here to here, we are good. I think this goes up to a little tiny via. Looks like that one there. Just have to poke through it a little bit. Yep. And on the other side, whoa, maybe it comes all the way up here somewhere and disappears. It ends up over there. And we're not shorted to any of the other traces, so yes, we are good there, finally. Last thing we're going to do is just apply a little bit of UV curable solder mask, just to kind of hold this wire in place, just because we don't want it to get ripped off at any point. Now all I need to do is find my UV light, which has disappeared. So we'll be back in a moment. Right, I found my UV lamp, so don't look directly into that. Yeah, this thing is pretty hectic, like you can actually sort of feel it on your skin. I also have this tiny pissy little one, and that was taking forever, so I'm glad I came across the big boy because that did the curing job pretty quickly. And yeah, that's now not going anywhere, so I'm happy that the underside of this board is now done. We can flip back to the top side. So as we saw, we lost quite a few components. Now, I'm not too worried about the passives, like the little capacitors and resistors. Hopefully I'll have stock of those so I can just replace them with their correct values. But for the transistors, we're missing at least 2 of them, possibly 3 of them. And originally I only found one that fell off the board, but I did find another one, and this was actually still in the Xbox case itself. So I basically turned the case upside down and tapped it a little bit, and this little guy fell out. So we've got those 2, we just need to work out where they're supposed to go. So let's refer back to before I touched the board and see what it looked like. So here's a pic of the board before I did any scrubbing. So yeah, we can see there are a couple of things that are still populated here that have now come off the board, but that's not a huge issue. Yeah, it's mainly just going to be these transistors, and it looks like possibly either this one or this one we're already missing. It's kind of hard to tell. Unfortunately, I didn't get a really good shot. This is just from the previous part of this video. So Yeah, I'm not 100% sure, but we should be able to figure this all out from the schematics, which thankfully are available on the console mods wiki. So down here, I think this is a 1.4 revision board. So they do have the schematics here. Unfortunately with these things, these schematics are not searchable. So if we scroll back up to the top, there is a little table of contents, but if we try and search for say C7G1, yeah, we get nothing because it's not searchable. And I did try and OCR this schematic, but that didn't really work out too well. I tried a whole bunch of different tools, but none of them are really good at working out what is on a schematic. I'm guessing because the font is a little bit sort of, I don't know, weird and notchy. And also, you know, this isn't really standard English. Nobody walks around and says VKT 70. So I think a lot of OCR software will struggle with this type of thing. But that's not a huge deal because we do actually have an index, which is an index of all the parts, on page 51 to 56. So here they all are. What's kind of annoying about these is it doesn't tell you what the actual values are. So R8B3, we know it's a resistor. And then we've got 35D3. So what this refers to is page 35 of the schematics. And then, is this 35? If we look in section D and scroll across to 3, was it R8B3? Anyway, we should be able to work out what values we need using these schematics. It'll just be a little bit of back and forth. And I'd rather replace the components that are missing with new components where possible, rather than trying to, you know, solder in the old ones, which are going to take quite a bit of effort to solder onto, and they also might already be bad. So I'd rather use new components where possible. So let's start off with C7G4. So if we take a look on here, all right, C7G4 should be on page 28, section D6. D6, here it is, C7G4, 1 microfarad, 16 volt, X5R, 0805. These things have been incredibly handy. They're little SMD sample books that I got from AliExpress. So this one's got a bunch of 0805 resistors, and I think in the back are 0805 capacitors. And I also bought one with 0603 sizes as well. Super handy to have. I'll leave links to where you can find these in the video description. So let's find 0805 1 microfarad, which should be this one right here. And these are X7R rated, apparently. It is AliExpress, so... Oh, it is so much nicer soldering non-crusty components. That's for sure. All right, one down, many to go. So C8G1 was unpopulated. We don't have to worry about that. Let's move into the danger zone. R7G2, we are missing. Let's find that. R7G2, 2.94K 1%. So it is a very tight tolerance. I really doubt I'm going to have that value. Yeah, I've got 3K. We can probably get away with 3K, but let me see if I can find the original part. It's probably going to be one of these ones that look really rough. Oh, and they're also going to be really hard to measure because they're so crusty. Oh, would you look at that? 2.944. If I can just scrape off some of the crust on this thing, maybe we can reuse it. Oh, one side's attached. And the other side, really should use the microscope, sorry. So I'm just going to try and get all these tacked in just to the point where they're not falling off the board, and then we'll inspect it under the microscope. R7G1 I managed to salvage, that's still in place. Not sure about that transistor. Q7G2, let's see if there was actually something there. Q7G2 is an NPN transistor, 34B7, let's see. All right, so there's Q7G2, it's a 3904 NPN transistor. Now, because I'm missing 3 spots on the board, but I only have 2 transistors, I'm hoping that one of them doesn't exist. I think Q7F4 is that one there, which is a 3906 PNP transistor. And the other one is this spot here, which I can't quite make out. Let's have a look at that photo. CP6F1. There's a CR6F1. I wonder if that's a 3-legged jobby. It definitely looks like a P. Oh, it is on that same page. Yeah, CR6F1. It is a diode. It's a 3-pin package, but only 1 and 3 are connected. I'm sure we can work around that, depending on what these two are. All right, well, looking at these under the microscope, one of them looks to be marked with 11X, and the other one, T1A maybe? Fuck. Oh, there it is. Oh, there we go. T1A35 and 11X. All right, using this cross-reference search, T1A does come up as a 3904 in a SOT23 package. So I reckon that's going to be our 3904, which I think is an NPN. Yeah. Surely that's got to be it. That needs to go at Q7G2. All right, that's installed. Again, we'll check all this under the microscope when finished. Let's go for the other one, which said, I think it was 11X or 11K perhaps. Xena diode. SOT23. It's not marked as a Xena on the schematics. So I'm pretty certain that this is a diode package. So the pin out on these, the bottom left is pin 1, the bottom right is pin 2, and the top pin is pin 3. So according to the schematics, it's only pins 1 and 3 that should be connected. So if we go between 1 and 3 this way, I do see a voltage drop of 0.6 volts, so that makes sense. If we swap the probes around, we see nothing. And pin 2 is definitely not connected to anything. So that's got to be our diode, which goes at this point here at CR6F1. And to confirm this fully, I actually went back through some of the footage that I originally shot and found a pic of what was originally on the board. So we can see that Q7G2 was the one that was missing originally, and that's the one I found in the Xbox case. And Q7F4 and CR6F1 are the two that I knocked off. CR6F1 is definitely this one that we've got right here. And I had a look around for Q7F4, and as luck would have it, I did actually manage to find it. So I threw this under the microscope, and on the top it says 2A, and after doing a quick cross-reference search, I did find that some 2As might be a PNP transistor, a 3906, which is exactly what the schematics also tell us. MMBT 3906 Q7F4. So we'll start with the PNP transistor because we've got all the pads here. And as for the diode, it just so happens that pads 1 and 3 are the two that are missing. And the second pad, which isn't connected to anything, is the only one that remains, but we'll work around that. Right, that seems good. Let's try and see if we can put this diode package back on and bridge these connections somewhere. I think if I angle it just right, we'll only need one little bodge. Just double check that. Yeah, pretty sure that's connected. Pin 2 isn't going anywhere, and pin 1, we're just going to need a little tiny bodge wire in there. So we should have continuity from here to pin 1. Yeah, I'm pretty sure that's good. Sweet. That is back in place. Now I did notice there's a spot here that says R6F7, but I wasn't sure exactly where this resistor would be because there doesn't seem to be any pads for it. So referring back to the schematics, I did actually find that there is indeed an R6F7. It's a 0 ohm 0402 size, which means it's absolutely tiny. It's one of these sizes. So that's probably why it doesn't look like it goes anywhere, because it actually sits between these 2 points here. And being that it's a 0 ohm resistor, I'm just going to put a little bodge wire over that joint as well. I don't have any 0402 0 ohm jumpers in stock. Right, so that should be our new 0 ohm R6F7. So we should have continuity between here and here. Sweet. Now it's just a few resistors and then we'll get all the electrolytics back in. Start with R7F9. Oh, yeah, here we go. R7F9 is a 2K resistor, 0603. Well, in that case, we should be able to use a brand new part to replace that. Yeah, easy. That's that one back in place. Then we've got R something something something. R7F8, and I think it should go there where that missing pad is, so we'll have to bodge that up as well. Looks like the only thing left is a tiny little via just next to where the pad was. Don't know if I'm going to be able to use that. So R7F8, one side should connect to pin 1 of Q7F3. Q7F3, pin 1, not connected to that pad. I bet you it's connected to that tiny bit of via that I probably can't solder to. Okay, so seeing as I can't really solder anything to that via, even though I can kind of probe it, I'm just going to put one end of the resistor here and then we'll run a little bodge wire from the other end over to pin 1 of Q7F3. Now, what value is it? 84.5K, 1%. I'm definitely not going to have that in my little parts catalog. So we're going to have to try and find the original. 84.6. That is within 1% of 84.5. It's got to be that one. Will I be able to solder that back onto the board though? Well, I just cannot get solder to stick properly on both sides of this thing, so we're going to give up on that, and I'm just going to use an 82K, which hopefully is close enough to 84.5. All right, another one down. I think there's hopefully only one resistor to go. And that is R7G2. Is it? No, it can't be. That's R7G2. What does that say? Oh, it's going to be connected to pin 2 of Q7G2. Should be pretty easy to narrow it down. Maybe it's R7G3. Yeah, it's got to be. 287 ohms. Ugh. That's 2K. I think we already sorted that out. 288.5. And it is very crusty, just like the other one. Oh, we got one side. Is it going to be as kind on the other side? I think so. Let's see what we get from here to here. 286.8. That is in there. So I think we should now have everything restored. Except for C7G7. Or is that the one that didn't have anything? C7G7. C7G7. Oh, it is listed. Okay, it's just a 0.1 microfarad bypass cap. We can throw that in. Although, I think I am missing some of the pad there, so we'll just use an 0805, which should bridge that distance. It should be big enough to fit across that gap. Yeah, I think we're good. All right, finally, I think we are done. So I'll get all these caps reinstalled. In fact, I'll probably just use new ones as a matter of course. Everything except for this coil, I'll probably replace with new stuff. All right, caps are back in, and yes, I did have to reuse these 1500 microfarad ones and this big 3300 because I don't have any of these in stock. However, I did test them on the LCR meter before putting them back in, and they were all perfectly fine. In fact, all of these little caps, which I did end up replacing with new ones, are also fine, all except for one. This one is a little bit out of spec. It's one of the 25 volt 22 microfarad ones. So putting it on the meter, I found it's a little bit low in capacitance, 18.4 microfarads with an ESR of 6.6. If we compare that to one of the other ones, which is also a 22 microfarad, 25 volt, they're a little bit better. 20 microfarads with an ESR of 4.5. The ones that I put in there, I measured at 21.2 microfarads, I think it was, with an ESR of 2 ohms. So even better than the original ones that were in there. Now, one thing I did forget to do is get this under a microscope to make sure everything looks good. So let's take a look. All right, so here's where we're at. Almost everything looks good. Not too sure about our little diode with the missing pad. I think a little bit more solder over there could help connect that a little bit better. It did seem to test okay with the multimeter, but it must be only just hanging on. That looks fine. It's a little bit messy, but what you're going to do? Yeah, I mean, these original resistors don't look great, but they seem to be connected. I might just touch up some of the joints on these, but I think they're going to be okay. Oh yeah, and that there too. I'll touch that up as well. All right, that is going to have to do it. It's still a little ugly, but everything should be reconnected properly, and we shouldn't have any future issues. Yeah, not perfect, but remember what it looked like when we started, and it doesn't look so bad. Now, there is one thing still to do. That's right, the clock cap. So I do have a 1.2 farad, 2.7 volt capacitor to go in the board, and yeah, it seems kind of crazy because the original clock cap is what caused all these issues, but I want to complete this repair job, and that means reinstalling the clock cap. For a lot of this stuff that we've just done, most of this circuit is just there to charge up the clock capacitor, so it seems almost kind of pointless fixing all this stuff if we don't put the capacitor back in. You can get away with running these boards without a clock cap. Pretty much anything pre 1.6 versions, which I'm pretty sure this is 1.4, will work just fine with the stock dashboard and no clock capacitor installed. For the 1.6 versions, I think you need to be running a modded dashboard or do a hardware mod on the 1.6 boards so you can run them without a clock cap and the stock dashboard. So yeah, we're going to put this in. I don't think it's going to leak like the original, but yeah, I guess ask me in 20 years' time. Now I do want to double check this with the multimeter because obviously some of these pads and the wires have been pretty much eaten away. It looks like this side is okay, and I'm pretty sure that's the side that connects to ground. It certainly does, so both those two pins are okay. Let's check the other two, see if we've got continuity between them. And we do not. Just flip the board over and have a look on the underside. Okay, so one of the pins definitely goes up through this trace and connects somewhere, looks like this tiny little resistor here. So that's still connected, and the other one is broken. So I don't see a trace on this side. It must have been on the top side between these two pads. There must have been a little bit of copper connecting those. But as long as both these holes are okay to use, we can stick with that. And maybe I'll set it off the board just a little bit in case perhaps one day it does leak. At least you'll be able to see it. So we should have a connection from here over to this little guy and from here to ground. Done. So we'll get the board reconnected and stick both drives back in, because without those, unless this thing has been soft modded, which I don't know if it has, I guess we'll find that out hopefully. Yeah, you do need both drives for this thing to actually boot properly. All right, everything is mostly reassembled, so the only thing left to do is plug this in, see if it tries to power itself up and get in some kind of boot loop, or if magic smoke comes out, or if it just works. Let's find out. We are plugged in. Okay, nothing happening yet. Let's power on. Sounds good. We've got something on the screen. Ooh, we do have video. It's a little bit unstable though. Do we have a disc? We've got The Simpsons Hit and Run. Sweet. Yeah, definitely very unstable, so there are still issues, dare I say capacitor issues, so I'm not going to leave this running, but it does boot, and it appears that it is not modded, I don't think. Well, now it's trying to boot the game. Let's not do that. Cool, all right. We're part of the way there. The next thing to do, of course, is to work out what's causing those video issues. We also need to replace the thermal paste as a matter of course. But I think we should really leave this video here, because I have multiple hours of footage, a few hundred gigabytes last time I checked to edit for this video. So I think that's going to do it for this one. I did really hope to get all 3 of these Xboxes done in one video, but yeah, there was never any hope of that the moment we opened this thing up. So that is it for this one. We'll be back with some more Xbox fun in the near future, but for now, thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are in the video description. You'll get ad-free early access to all videos, along with discounts on the Tindy store and other exclusive updates. And yeah, so thank you all for watching, liking, subscribing. All that YouTube stuff really does help. And yeah, I will hopefully catch you in the next one. Bye.